Do you have any idea what we learned? At least if you brief what we learned, then I will explain the next topics. What are the topics till now we learned? Please let me know.
Spherical coordinate system, ma'am.
Yeah, spherical coordinate system. So that is the last topic, right? We learned
Yes, ma'am.
about cylindrical coordinate system, rectangular, I mean cylindrical. First one is Cartesian or rectangular coordinate system. Next one is cylindrical, and last one is spherical. And we know the relations between each and every one. What is the relation between rectangular coordinate system and spherical coordinate system? Similarly, spherical coordinate system and cylindrical coordinate system, right? Everything we learned in our previous class. The relations also we learned means how to convert from spherical coordinate systems to rectangular coordinate system, or rectangular coordinate systems to okay. Now we will see here. This is visible, right? The screen is visible, right? Yes, ma'am. Screen is visible.
Yes, ma'am.
Yes.
Yeah. So all these things we learned in our last class. Now here is a problem how to convert the following points represented in a cylindrical to rectangular coordinate system. Means given parameters or cylindrical coordinate parameters. So what is the meaning of cylindrical coordinate parameters? What are the basic three parameters of a cylindrical coordinate system? ఏంటి three parameters of a cylindrical coordinate system? What are the three coordinates of a cylindrical coordinate system? Rectangular ఏంటి three coordinates? X, Y, Z. What is the coordinate system parameters for cylindrical? Rho, pi, Z. And what are the parameters for spherical coordinate system? R, theta, and pi. Now what is given? The given parameters are rho, pi, and z. I forwarded the same notes in your class group also. You can go through it. Rho, pi, z are given. So if rho, pi, z are given, what I want to find out? I want to find out x, y, z. Now what is the relation between cylindrical and Cartesian coordinate systems? Z is equal to z as it is, but x is equal to rho. What is the formula? Rho sin pi or cos pi? Rho cos pi and rho sin pi, right? X is equal to rho cos pi and y is equal to rho sin pi. So rho cos pi, the rho value is mentioned and also pi value is also given. So you can find out by substituting the values, which gives rectangular coordinate system, I mean cylindrical to rectangular, you can convert, right? And one more thing is your vector is given. Previously, just simply a points are given. Coordinate system points are mentioned. Now, what is the given one? Here given is coordinate system. Vector is given f bar is equal to 4ax bar minus 2ay bar minus 4az bar. Located at 2, 3, 5. And the points are given as 2, 3, 5. Convert into cylindrical. Ax, ay, az is mentioned means it is given in rectangular coordinate system. You have to convert this to spherical coordinate system. You have to convert it to cylindrical. So the relation between cylindrical coordinate system and rectangular coordinate system is a rho a pi az is equal to cos pi sin pi 0 minus sin pi cos pi 0 0 0 1 ax ay az. Ax ay az points are given as the component values are given as 4 minus 2 and minus 4. Substitute 4 minus 2 and minus 4. Points are given as 2 3 5. So 2 3 5 means these are x y z. So if you want to find out rho, what is the rho value? Under root x square plus y square plus z square. Then what is the pi value? Tan inverse y by x. If you substitute tan inverse y by x, then you will get angle value. So substitute cos pi, sin pi and minus pi, sin pi, cos pi, you will get calculate a rho, az and a pi values. This is the way of converting rectangular to cylindrical to rectangular and rectangular to cylindrical. Similarly, spherical coordinate system, this also we can learn how to convert parameters and this is the problem. Next one we will see what is line surface and what is volume and surface integrals. We are going to learn about a line integral. What is a line integral? Means how to calculate a line integral. Means the total flow of energy through this line or through this curve, or if you curve is a closed circle like in the form of a circular curve, then how the total flow of energy or flux density, what is the flow of energy, the total energy or current flowing through this line. If I want to find out the total current flowing through this line, what I want to do, if the starting point is A and ending point is B, if I know the current flowing through at each and every point, if it is not a discrete means you can add from point A to point B, how many intermediate points are given. At that points you can add, then you will get the current flowing through that total line. But here, if it is a continuous, you are not going to add. It's not possible to add. So what you have to do? You have to do integration, integral of. That gives integration. So what is line integral and what is surface integral? Surface means if I want to find out the area of a surface, then I can go with surface integral, and the one is volume integral. So if I want to consider open, if it is a open surface, then I am going to consider surface area. If I am going to consider this as a closed one, then I have to consider volume. If any surface, whatever you are considering, that is open type, then you are going to calculate surface area. If it is a closed one, then you have to consider volume integral. So we have three basic parameters: line integral, surface integral, and volume integral. నేను ఎన్నిసార్లు చెప్పాను, మీరు ఎప్పుడు జాయిన్ అయ్యమని చెప్తున్నాను నాన్న. 28-15కి జాయిన్ అవ్వాలి, అట్లీస్ట్ 20 వరకు అలో చేసా. So what is line integral and what is volume integral and surface integral? These three we are going to learn about now. So line integral is also called as curve integral. Line integral is also called as, if it is in the form of a straight line, then it is line integral. If the line is in the form of a curve shape, then it is called as curve integral. Or if it is closed like the line, I can say like this is point A and B, right? Here I'm considering point A, B, and somewhere I'm considering C. So if I'm considering A, B, C, A as one line, if it is in the closed form, circular form, then it is considered as counter integral or curve integral, line integral, curve integral, or counter integral. We have three names: line, curve, counter integral. Line, same line integral only. Means here we are going to calculate throughout the circumference. Circumference comes under line. It's not comes under the solid value. Means area. It does not give area value. It gives only a line type. Means circumference type. So line integral, how to find out the line integral? So I'm considering a point, a vector field A. Okay, a vector somewhere it is going to present. So a vector A I am considering. What is the total field? What is the total field present throughout this line? What is the total field strength flowing through this line that I want to calculate? So if I want to calculate total field strength flowing through this line, means I can do integral from where to where. I can do from A to B. And what is that line, vector given A? Line integral means if you are integrating throughout the line, means this is represented by dl, A dot dl, or simply you can write it as A dot dl. If the limit values or don't know, then I can write integral is, there is no limit values, upper limit and lower limit. I can represent simply it as A dot dl. The total electric field or total potential flowing through that line is given as A. Throughout the curve L, if I am considering a curve L, then the total field strength is given as line integral of L is represents, here the L means it represents line integral of A dot dl. So what is the values here we consider? For this curve, the upper limit and lower limit is A to B. Throughout this A to B, what is the total field strength flowing for a given vector A? So that is A dot dl. So A to B, A dot dl. What is A? A is a vector. Vector means it's having both magnitude and direction. Magnitude and phase or magnitude and direction. So the magnitude value is given as mod of A into angle is given as cos theta, means in which direction it is flowing, that is given by theta. So mod A times of cos theta dl. This is the total field strength of this vector flowing from a line A to B. If I'm consider A to B only, now what I'm doing, I'm going to close this curve. I'm going to close this curve and somewhere I'm going to consider a point C. Then what I can consider? This is the line integral, which is a closed curve, which is in the form of a closed curve. Then how to calculate the line integral? If it is in the form of a closed curve. Throughout the line, see how it is mentioned. Both are same, but if it is a open curve, no need to represent any circle here. If it is a closed curve, then you have to represent this circle. The circle means circular curve or it is a closed curve. Closed curve means it is represented by this form. Vector is same A. This vector is present in this field wherever we are considering. So what is the total field strength of this vector throughout the given line? Throughout the given line means here it is A to B only, but if it is simply a curve from A to B, then there is no closed circle in the center. If it is closed curve, then you can represent this A dot dl. A dot dl means A is a vector. You can represent vector like this. Simply instead of representing A, you can represent A bar. So then I can represent closed curve of A to B. Then vector is having both magnitude and direction. So magnitude is given by mod A, and towards which direction we are considering that curve, that line is vector is flowing in this direction means throughout this line it is in an angle of theta. So angle is given by theta, the direction is given by cos theta into dl. This gives the total circular, for a circular curve, the line integral is calculated like this. So for a line integral, integral of closed integral of A dot dl. Okay, ma? Now what is surface integral? What is the difference between line integral and surface integral? Here same I am considering length. If I am representing here L for a integral, if I am representing the suffix as L, then represents line integral. If I am representing S, if I am representing S, then it is a surface integral. For surface integral, vector A I am considering. What I want to consider here is length is dl, but surface is ds. The surface area is represented with the integral of ds. And one more parameter you have to consider here, an cap, an bar. Why I am considering an bar means in which direction it is flowing. What is the total field strength which is flowing? That is you have to mention. The total surface area is given as, if I consider the rectangular coordinate system, a surface we consider in the rectangular coordinate system towards y and z direction, then how the total surface area is given by? The surface area of this one is with respect to y, the length value is dy, with respect to z, the length value is dz. Then what is the surface area here? Dy into dz into an bar. That is an bar means throughout the x direction. The surface area is mentioned like this. Dy dz ax bar, normal to the surface area. So that is you have to consider. So surface area is calculated as that the total flux generated in the surface is given as a total field strength. Flux means the total strength, how it is moving. So that is represented as I is equal to surface integral of a dot, see here, a dot an is a normalized factor or normalized unit vector which is perpendicular to the given surface a dot an into ds. What is a here? A is a vector, I said, right? So if it is a vector, you can write it as surface integral of A bar means here I can write it as mod A times. What is the angle value given? Angle value is given as cos theta into an cap ds. An cap into ds. This is the total surface integral of a given vector. Given vector surface integral is given like that. So it gives the total amount of field strength flowing from that outwards, not inwards, right? It is flowing from that surface. How much field strength is generated from that surface is given as surface integral of a dot dx, which is represented by the psi. Psi gives flux. Flux of a total field strength or flux is represented by psi is equal to surface integral of a dot ds. Okay. Here it is a closed path. Surface means it represents closed path, but the surface is a open surface. It is not a closed surface. Surface, whatever we are considering, it is a open one. If you are considering in the form of a closed surface, then we are going to calculate the total volume present in the closed surface. So volume integral is given by, in place of S, L, we have to represent it by V. So what is the total charge present in that closed surface? If it is open surface, then in that open surface, I am considering the small area, how much area it is, surface area, surface integral. If I am considering this in the form of a closed surface, like you can consider a cuboid. So if it is closed surface, then how to calculate the total charge present in this? The total charge present or generated in this volume is calculated as rho v. Rho v, volume integral of charge is the total general how much charge is present in this one. If I want to calculate the total charge means total volume I want to find out. So volume integral of rho v dv. This gives the total uh, charge present in this given cuboid or given cube. So volume integral, if you have to calculate, means the surface should be closed one or the given object should be in the form of a closed one. If it is open one, then you can calculate surface area, not the volume. Okay. These are the three important ones. So we are going to use these in our actually required subject in our EMTL. All these, whatever I am saying, this is introduction only. We never enter into, till now we didn't enter into our subject. But this is also important one. Sometimes they will ask questions according to this one also. Now, so this is the problem I considered. So, given vector f bar is equal to x square ax, xz ay minus y square az. Here it is given like a vector form. Ax, ay, az direction components are given means it is in the form of a vector. Okay. The circulation of f around the closed path. It is given as closed path shown in the figure. Okay, the circulation of what I have to find out, I have to find out path. Path means it is a line integral. If it is mentioned like a path, closed path means you have to consider it as a line integral. It is not like area. Area and mention cheyaledu, volume and mention cheyaledu. Simply they mentioned it as path. Path means circumference. So what is the total line integral I want to find out? So to find out the line integral, what is the given one is, see here, x నుంచి ఒక పాయింట్ 1 తీసుకున్నాము. So 1 is moving from x to 0, then 0 to y it is mentioned as 2. From y to somewhere else it is present in the yz coordinate system, it is 3, and from that yz coordinate system point to again x, then it is considered as 4. So the closed line, it is given like a closed path or closed line. So how to calculate the line integral? In general, you can calculate the line integral if it is given in the normal coordinate system. Here it is given like x, y, z coordinate system. So I'm considering, I'm dividing this closed path into 4 points. If it is given like from x to somewhere else, then again it is moving this direction, it is the origin. This line is 1, this line is 2, and yz coordinate system somewhere else in the yz place, then it is the third line. From here to here I can consider it as line 4. So what I'm going to do, if I want to calculate the total, the electric field generated through the, while flowing from this path, means how it is, I can calculate integral of first point, first line. First I'm calculating for this line, and then I'm calculating for the second line, then third line, then fourth line. Add together, then whatever you are getting, that is the total line integral. Total line integral. So I'm going to add four parts. Line integral of 1, 2, 3, 4, and which factor? A dot dl, right? Here A is mentioned as f dot dl. So for the first segment, you are considering segment 1. So what is the segment 1? X to 0. It's completely related to x parameter. What is the y value for this line? Y is 0 and z component is also 0. Only present along the x axis. So x axis ఉంది అంటే yz values ఏమవుతుంది? Always it is 0. There is no y and z component. So assume y is equal to 0 and z is equal to 0. Substitute in f. So f లో substitute చేస్తే we will get only one component is that is x square ax. So integrate. Integral of line integral, right? 1 f dot dl. So 1 f dot dl means what is the one line one limit values? Maximum is 1 and minimum is 0. So 1 to 0 x square dx. If you simplify, you'll get line 1 integral, segment 1 integral. Similarly, I want to calculate for line 2. Line 2 along y-axis only. Y-axis means x and z components are 0. Similarly, you can substitute x and y components 0 in the given f. So what you'll get, x and z are 0 means you'll get minus y square az. You'll get minus y square az. But az is also 0 because there is no az component. So it is equal to 0. Segment 2 is 0. Next, segment 3. If you observe here, segment 3 contains y and z components. It contains y and z components. So I have to consider here segment 3, y is equal to 1. It is present in the third coordinate system y and z, right? Y is equal to 1. So if you substitute y is equal to 1, what you will get? F value is x square ax minus xz ay minus az. So substitute that and simplify. Then you will get line segment 3 total length value. Similarly, fourth line. For fourth line x is equal to 1 we are assuming. Then if you simplify, you will get minus 5 by 6. So add all these components which gives the total line integral. The total line integral is segment 1 line integral, 2, 3 and 4. Then you will get the total power. Now here, so line integral, volume integral and surface integral means to find out the total charge distributed throughout the line, a total charge distributed throughout the area, or to find out the total charge distributed throughout the volume. Okay. So to find out that, we are using line integral, surface integral and volume integral. Now what is the different operators we used in this electromagnetic waves? What are the different types of operators we used? Okay, we are going to use only two operators. One is del, another one is curl. We are going to use only two operators. The two important operators used in this electromagnetic waves is del operator. This is symbol like a triangular, which is a reverse triangular form, and curl operator. Del operator, I mean dot, it represents, this is the del, and what is the operations we are using means del dot a vector or a scalar, and the one is del cross a vector or a scalar. These are the two required operators. What is del? It is a differentiation form. Del means this symbol represents the differentiation of a signal, the differentiation of a vector or scalar. This is represented as dou by dou x times of ax. In the ax direction, we are going to differentiate with respect to dou by dou x plus dou by dou y times of ay. If you are considering v, del dot v means here you will get v. Here you will get v. But what is the operator del? The del operator simply represents dou by dou x of ax, dou by dou y of ay plus dou by dou z of az. The del operator represents dou by dou x of ax, dou by dou y of ay, and dou by dou z of az. Now, where I am going to use and how I am going to use. What are the two types of This is del. We can say the name of this symbol as del or gradient or gradient. Both. It is named as del or gradient. Del dot D gives the divergence of a vector. Divergence, how it is distributed throughout the field. If the vector is given dou by dou x, dou by dou y and dou by dou z means throughout a rectangular coordinate system, how it is distributed, how the vector V is distributed, how it is distributed, that is given by the operator del or gradient. That is a del operator is a differential operator. The differentiation form is given as del. For Cartesian coordinate system, it is dou by dou x, dou by dou y, dou by dou z. Cartesian means rectangular coordinate systems. If it is in the form of a cylindrical coordinate systems, then dou by dou r, dou by dou pi. See here, for rectangular cylindrical coordinate systems, dou by dou rho a rho, 1 by rho times of dou by dou pi of a pi plus dou by dou z of az. I mean, how we got here 1 by rho means, if you know the relations, we have dou by dou x, dou by dou y and dou by dou z, right? If I want to find out this, convert this into a cylindrical coordinate system, then I have to use the relations. What is the x? X is equal to rho cos pi and y is equal to rho sin pi. Y is equal to rho sin pi and z is equal to z. So if you want to convert this in terms of dou by dou rho and dou by dou pi and dou by dou z, dou by dou pi and dou by dou z times. Simply differentiate this with respect to x. Then what you will get? Dou x is equal to, or dou by dou x is equal to, with respect to x if you are doing, then what you will get? Dou by dou x is equal to dou rho by dou x. This is uv, right? You have to do with respect to uv format because this depends on the x value and pi also depends on the x value, and differentiate with respect to x. Similarly, this also differentiate with respect to x and y. Then you can simplify, you will get the relation between dou by dou rho, dou by dou pi and dou by dou z. See here how it is. Dou by dou x and dou by dou y we calculated by using uv. Then you will get cos pi times of dou by dou rho minus sin pi times of rho by dou by dou pi. So simplify and substitute in the equation 1, then you will get cylindrical coordinate systems. Similarly, spherical coordinate systems also you will get. For spherical coordinate systems, the parameters are r, theta and pi. So dou by dou r times of ar plus 1 by r into dou by dou theta times of a theta plus 1 by r sin theta times of dou by dou pi of a pi. This is the del operator in spherical coordinate system. Equation 2 gives the del operator in cylindrical coordinate system. Equation 1 gives del operator in rectangular coordinate system or Cartesian coordinate system. So what it gives, we can use del V. The divergence of the vector is del dot A. Curl of the vector is del cross A. And Laplacian. So I said two operators, right? Del dot V, which gives the divergence, and curl of the operation we can calculate it as del cross V. And one more thing is del dot del V. This is considered as del square V. Del square is a Laplacian. Okay, divergence operator we have, curl operator we can calculate, and Laplacian I can calculate. These three I can calculate by using this del operator. Del dot A, del dot V is for scalar, del dot A for vector, del cross A and del square V. Okay, now how to find out del dot A or del cross A and del square V for three coordinate systems: Cartesian coordinate system, rectangular coordinate system and spherical coordinate system. And can you tell me what is the del operator for cylindrical coordinate system? Anyone? What is for cylindrical coordinate system? Yes, ma'am. Rectangular can be del ante. What is the del operator for rectangular coordinate system? Just once you brief, then you can do it for different vectors and scalars. So del operator, can you please tell me what is the del operator in the rectangular coordinate system or Cartesian coordinate system? Yes, ma. F naught. S. F naught. Are you there? F naught. D naught. ఎవరిని పిలిస్తే వాళ్ళు లెఫ్ట్ అయిపోండి అటెండెన్స్ కూడా నేను ఇప్పుడే వేసేసుకుంటా పిలిచిన వాళ్ళు రెస్పాండ్ అవ్వకపోతే ఐఎమ్ గోయింగ్ టు గివ్ సింప్లీ యాబ్సెంట్ నెక్స్ట్ డి నాట్
Yes, ma'am.
యా వాట్ ఈస్ ద డెల్ ఆపరేటర్ ఇన్ రెక్టాంగులర్ కోఆర్డినేట్ సిస్టమ్ ఎలా చూపిస్తాం దాన్ని రెక్టాంగులర్ లో లెస్ E8 అసలు ఈయన ఎప్పుడు కాలేజ్కి కూడా రాడు ఈరోజు క్లాస్కి వచ్చాడు ఆన్లైన్ కదా అటెండెన్స్ వస్తుందని వచ్చామన్నమాట lateral 13
Ma'am.
yeah tell me what is the del operator ma C9
Ma'am, dou by dou x into x plus dou by dou y
yes
into ay plus dou by dou z into az, ma'am.
very good dou by dou y into ay plus dou by dou z into az అట్లీస్ట్ నేను నోట్స్ పంపించానని కూడా చెప్పా క్లాస్ గ్రూప్లో అది ఓపెన్ చేసైనా చూడొచ్చు ఎస్ మా D1 what is the del operator in cylindrical coordinate system D1 is there D1 is there D5 C4 C4 D4 Esma respond what is the del operator in cylindrical coordinate system dou by dou rho of a rho plus 1 by rho times dou by dou pi of a pi plus dou by dou z this is as it is dou by dou z times of az similarly what is for spherical coordinate systems r theta pi so dou by dou r of ar plus what is for theta 1 1 by r times of dou by dou theta times of a theta see here you can find dou by dou theta times of a theta 1 by r sin theta times of dou by dou pi of a pi this is for the del operator in spherical coordinate system now we calculate for one vector we'll calculate the same function for one vector then del v in a rectangular coordinate system I'm considering del v is equal to dou v by dou x dou v by dou y dou v by dou z simply we are substituting in place of dou by dou x as dou v by dou x of ax dou v by dou y of ay and dou v by dou z of az that is for rectangular coordinate system simply cylindrical means wherever you have dou by dou You can substitute it as V. Dou V by dou R, rho of AR, dou 1 by rho times of dou V by dou pi of A pi plus dou V by dou Z. Similarly for spherical coordinate systems also. What is spherical coordinate system? Dou by dou R of AR, right? So in place of this dou by dou R, dou V by dou R. Then 1 by R times of dou V by dou theta times A theta plus here 1 by R sine theta times dou by dou pi. So dou V by dou pi times A pi. This is for spherical coordinate systems. Any vector is given. So for that vector you can, or scalar. If it is given like a scalar, simply you can substitute. Okay, that gives the gradient of a scalar, or del of a scalar, divergence of a scalar in terms of cylindrical, rectangular or Cartesian, and the one is spherical coordinate systems. So what are the different properties? See, del of u plus v is equal to del v plus del u. uv means same integral differentiation in came formulas unnai ave. It is differentiation with respect to three-dimensional format. Simple ga manaki d by d ante enti differentiation. Differentiation of with respect to x ఒకటే చేస్తాం మనం. But here, if this operator is using, it will differentiate with respect to three parameters, coordinate parameters. That is the only difference. If you are using simply differentiation, then it is for one parameter only. If you are using the operator del or gradient, then it is with respect to three parameters differentiation. It is with respect to three parameters differentiation. That is the only one difference between differentiation and del operator. Okay, so what is the differentiation of u formula? V du plus u dv. Similarly, u by v. U by v differentiation ఏంటి? V du minus u dv by v square. Same అలాగే ఇది కూడా. N times of differentiation means n into v power n minus 1 times of dv. Okay, it gives the maximum rate of change per unit distance. Differentiation always gives maximum rate of change with respect to the given parameter. This also gives the direction of maximum rate of change and it is perpendicular to the surface, the given vector surface. Divergence of your operator. So how to find out? Previously, whatever we calculated is for scalar. V is a scalar. Scalar means the final output is in the form of, it does not give any direction. It gives only magnitude. That is the scalar value. But here we are considering vector. If you consider a vector, then what is the del dot A bar or del dot V bar? Bar means it represents the vector value. So the total power generated or the total field strength, here it is mentioned in terms of flux. It is mentioned in terms of flux. The field generated by using the given vector at point P, at a particular point P, what is the total field strength generated or what is the total flux or field generated because of the given vector, that is given as divergence of A bar or del dot A bar. Del dot A bar. Del dot A bar is simply given as limit del V tends to 0, closed surface integral of A bar dot ds bar by dv. Means throughout that surface, what we consider here, I am going to consider at a point P. I am using a vector A bar. So how it is generated, how it is radiating its signals? This is a field strength. So vector I consider at a particular point A bar. How it is generating the field? It will generate in all the directions, not only in one direction. So whether the field is going out or the field is coming inside. Whether the field is going out or coming inside. So you have to consider. So how I am considering that field strength? I am considering the total field as throughout the surface. If it is traveling only in one line, then I can use line integral. But here a point P, which is placed in the space, a vector is present. So vector is present means how it is distributing its charge. How it is distributing its charge throughout the surface present at this point. So that is given as surface integral of this A bar dot ds. A bar dot ds, where ds is the surface integral by del v. That is the volume, the total volume I am considering del v, limit del v tends to 0. So if it is moving outside, if I am considering the charges or the charge is moving outwards, flowing outwards, then it is considered as a positive charge, a positive divergence. If it is coming inside, the charge is flowing towards inside to that point, means we are capturing. One is in the case of transmitter side and the one is case of receiver side. We are capturing from the free space at a particular point, then it is considered as negative divergence. Positive divergence and negative divergence. Sometimes it is zero, means how much it is flowing outside, same is coming inside. So the total field strength is zero. Outwards is equal to inwards, then it is zero. Outwards is considered as a source. Transmitter అంటే ఏంటి? మనం జనరేట్ చేసిన దగ్గర నుంచి ఇట్ నీడ్ టు ట్రాన్స్మిట్ ఆర్ ఇట్ నీడ్ టు ఫార్వర్డ్ టు అవుట్ సైడ్. సో పంపిస్తున్నాము అంటే దట్ ఈస్ ఏ ట్రాన్స్మిటర్ పాయింట్. ఇట్ ఈస్ ఆల్సో కన్సిడర్డ్ సోర్స్. Transmitter or source point. If you are capturing the total field strength present in a particular point, so if you are capturing means it is coming towards, so it is coming inside means then it is considered negative divergence or it is considered receiver or sink. In general, the name is considered sink, source and sink. Source is outward, sink is inward. Sink is considered as inside. Convergence, divergence, or you can also cite inverse can also be considered as convergence. The field is convergence and the field is divergence. Here the field is divergence and here the field is convergence. Source point and the sink points. Okay, for this a bar, now how to calculate? It is a vector, right? So for this vector, how to calculate the del operator? I am considering a bar as a vector. Sorry, yeah, vector. A bar is vector, means how can represent this vector? It is having direction component ax and ax component and ay component. Component is represented with the direction also, and az component into az, right? This is the vector, I mean given vector A. Now I want to find out divergence of this a bar, del of this a bar. So del of this a bar is equal to, what is general formula? Dou by dou x of ax. So dou by dou x of, I am applying, see how I am applying ax. Here I have ax component and here also I have ax component. So ax dot ax, ax dot ax dot ax is 1 because they are in same line. The del product, the dot product of same components is equal to 1 because why it is 1? Cos theta, the angle between these two. Dot and cross product నేర్చుకున్నాం కదా. What is the meaning of dot product? AB cos theta. So what is the angle between AX and AX? AX and AX is 0 degrees. So it gives cos 0. Cos 0 is 1. AX is a unit vector in the x direction and A is also a unit vector. So 1 into 1 is 1. So you'll get its value as 1. That's why I can write it as simply dou AX by dou X plus dou AY by dou Y, because AY into AY is again 1 plus dou AZ by dou Z. Dou AZ by dou Z. This is our divergence of a vector. This is divergence of a scalar. Now, right? So, if you can represent, this is for Cartesian coordinate systems, or you can say it is for rectangular coordinate system. If it is for cylindrical coordinate system, then what you will get? Dou A rho by dou rho plus 1 by rho times of dou A pi by dou pi plus dou Az by dou Z. This is for cylindrical coordinate system. If it is for spherical coordinate system, what you will get? Here in place of dou by dou rho, a v vector, I can represent it as AR. I can represent it as AR. This AR component will be closed. It becomes 1. 1 by R times of dou A theta by dou theta. This A theta becomes 1. 1 by R sin theta of dou by A pi. A pi times of dou pi. This is the divergence of a vector. the divergence of a vector. See here how we calculated divergence of a vector for cylindrical coordinate systems. 1 by rho times of dou pi of rho ar అంటే ఏమవుతుంది రో రో క్యాన్సిల్ అయిపోయి డో రో టైమ్స్ ఆఫ్ ఏ రో ఇక్కడ కూడా అంత ఆర్ స్క్వేర్ క్యాన్సిల్ అవుతుంది డో ఆర్ ఆఫ్ ఏఆర్ ప్లస్ 1 by r sin theta means here simply you will get 1 by r into dou theta of a theta 1 by r sin theta into dou by a pi of dou pi. These are the divergence of a vectors. Divergence of scalar we learn and divergence of vectors we learn. Similar to our divergence property, I mean del, here it is for scalars we observe. These are the formulas for scalars, right? So same if you apply for the vectors, then what is the product of this one? Del of a dot b is equal to del dot a plus del dot b. Del dot va is equal to one is vector and another one is scalar means v of del dot a plus a dot del v. And see here one more last property. This is very important property of a divergence parameter. Divergence of a vector and also called as divergence theorem. Surface area of surface integral of a dot ds where a is a vector, right? So surface integral of a dot ds is equal to volume integral of del dot a dv. Volume integral of del dot a dv. This is one of the properties of the divergence theorem. So what is divergence theorem means? The volume integral of divergence of vector A is equal to the closed surface integral of the same vector, or surface integral or closed surface integral of the vector A is equal to the volume integral of divergence of A. This theorem, divergence theorem, states that the total outward flux or the total flux flowing outside of a vector A through the closed surface S is same as the volume integral times divergence of A. This comes under divergence theorem or divergence properties. So once we learn divergence, now what is the next operation? Del dot V or del dot A. One is vector, another one is scalar. This is scalar we consider, this is vector we consider. Same del dot operation we observed, we have two operations. One is dot product and the one is cross product. So what is cross product? How to calculate the cross product of vector and how to calculate the cross product of scalar? That is in our next one. Curl of a vector means the cross product. So I'm considering what is the cross product of a vector A bar. So to calculate the cross product of a vector A bar, del dot A dl, del cross A, curl of A bar, cross product is represented as curl of A bar is equal to del cross A bar is equal to limit delta S tends to 0. This is the formula in general, but here this formula we are not going to use. What we are going to use is for rectangular coordinate systems, the dot product is calculated, that is curl, cross product is calculated by using the det operation. Last class the curl operation chusam kada, previous curl operation how to do. I mean cross product ela chestamani cheppam, ax, ay and az, dou by dou x, dou by dou y and dou by dou z. Ax, ay and az. This gives del cross a bar, that is curl operation of a vector. This is the formula used to calculate the det of, this one gives curl of a vector a bar in the cylindrical coordinate rectangular coordinate system. Similarly, what is the curl operation of a vector in the cylindrical coordinate system is 1 by rho times of, this is the formula. And for spherical coordinate system, 1 by r square sin theta times this one. You have to remember these formulas. 1 by rho times of a rho a pi, az, dou by dou rho, dou by dou pi, dou by dou z, a rho a pi, dou z, az. Okay, 1 by r square sin theta times r a theta, r sin theta a pi, dou by dou r, dou by dou theta, dou by dou pi, r a theta, r sin theta a pi. This is for spherical coordinate system, the curl operation. Now, the important one is What are the properties of curl operation? So curl of, that is del cross A plus B is equal to del cross A plus del cross B. If you observe the cross operation here, del cross A cross B, like associative property if you consider, del cross A cross B is equal to A times of del dot B minus B times of del dot A plus B times of del dot A minus A times of A dot del times of B. This is the formula for A cross del cross A cross B. And if it is vector times of scalar, then this is the formula. Del cross A is equal to 0. Del cross del dot V is equal to 0. Del cross A is equal to 0. Del cross del dot V means divergence of curl of any vector is equal to 0 and curl of divergence of any scalar is equal to 0. These two you have to remember, that is divergence of curl of a vector is equal to 0. Curl of divergence of a scalar is equal to 0. V and a vector unco, this is scalar. A means a vector I am considering. Then, by using these properties of a curl operation, that is, I am going to propose one more theorem, that is Stokes theorem. Stokes theorem means, in the previous case, divergence theorem, we said, what is divergence theorem? Volume integral of divergence of a vector is equal to closed surface integral times of that vector, closed surface integral times of that vector. So but here, there we consider volume and surface integral, but here we are considering line and surface integral, so volume divergence of volume integral we consider, divergence of a vector of volume integral. In this case we consider divergence theorem is closed surface integral of vector a bar dot ds is equal to integral times of volume integral. Here I am considering volume integral times of a dot divergence, right? It is del dot a, divergence of a dv. This is divergence theorem. Now see what I am doing. Simply I am replacing here volume, I am going to replace with surface. Yes. Del dot A, divergence I am considering curl operation. Divergence is replaced by curl of ds is equal to, here it is surface. Surface previous one is line. So closed line integral of a bar dot dl. A bar dot dl. This is Stokes theorem and this is divergence theorem. See here both. A dot dl is equal to surface integrals times of curl of a bar. Curl of a bar dot ds. This is Stokes theorem. What is Stokes theorem means? The closed path, the total field generated by a vector A throughout the closed path is equal to the surface integral times convergence or curl of a vector A. Curl of a vector A. That is our Stokes theorem. Then what is Laplacian? Means we consider single operator del dot vector V or del dot scalar V and vector A bar. And similarly we consider cross operation, that is curl operation of these two. And what is the another one we are considering? Two times of del operation, del dot A, which is del square of A, del square of A or del square of V. That is our Laplacian of a scalar. So you can consider scalar del dot del V is equal to del square V. For Cartesian coordinate system, cylindrical coordinate system, spherical coordinate system, it is same. Okay. This is about our introduction part. Esma, you have any doubts in this? Yes. మంచిగా మళ్ళీ అందరు జాయిన్ అయ్యారు అటెండెన్స్ కోసం. పిలిచినప్పుడు క్వశ్చన్కి ఆన్సర్ చెప్పడం రాదు, బట్ యూ వాంట్ అటెండెన్స్, రైట్?